We want to simplify the given expressions using the properties of exponents given here below for reference. We first have 5n times 7n to the third raised to the second power. Looking inside the parentheses, 7n to the third means 7 to the first times n to the third, and therefore here we have powers raised to powers, so we multiply the exponents. So we would have 5n times 7 to the power of 1 times 2, or 7 squared, times n to the power of 3 times 2, which is 6. And since 7 to the second is equal to 49, we'd have 5n times 49 n to the sixth. And now when we multiply here, remember n is n to the first, so we multiply the coefficients. 5 times 49 is equal to 245. N to the first times n to the sixth. The bases are the same, and therefore we add the exponents when multiplying, so we have n to the seventh. So we have 245 n to the seventh. Another way to approach this would be to expand 3n to the third raised to the second. If something is being squared or raised to the second, we know we have two factors of the base. So let's also show this another way. We can also think of this as 5n times 2 factors of 7n to the third. Again, this is n to the first. So multiplying here, we multiply the coefficients. 5 times 7 is equal to 245. And n to the first times n to the third times n to the third. We're multiplying, the bases are the same, so we add the exponents, giving us n to the seventh. And as we can see, we do get the same result. Next we have negative 2x to the second raised to the third power. So inside the parentheses, we have negative 2 times x squared, or if we want negative 2 to the first times x squared, all raised to the third power. So we have powers to powers, so we multiply the exponents. We do have to be careful when we have a negative coefficient like we do here. We do need the negative 2 in parentheses, raised to the power of 1 times 3, so we have negative 2 to the third. Then we have x to the power of 2 times 3, so we have x to the sixth. So here, negative 2 to the third will have an odd number of negatives, so this will be negative 8 x to the sixth. On problems like this, when we have a negative coefficient, we do need to be a little extra careful with the signs. So again, we have negative 8x to the sixth. Of course, the other option would be to expand negative 2x squared raised to the third, meaning we could also write out 3 factors of negative 2x squared. So there's one factor of negative 2x squared, there's a second, and there's a third. Now if we multiply, negative 2 times negative 2 times negative 2 is negative 8, x to the second times x to the second times x to the second. Again, we're multiplying, the bases are the same, so we add the exponents, giving us x to the sixth. And again, the same result. Next we have 3x to the eighth squared times 2x to the sixth raised to the third, or 2x to the sixth cubed. So again, this is 3 to the first times x to the eighth. This is 2 to the first times x to the sixth. So because we have powers to powers, we multiply the exponents. So we would have 3 to the power of 1 times 2, or 3 squared, times x to the power of 8 times 2, that's 16, times 2 to the power of 1 times 3, so we have 2 to the third, times x to the power of 6 times 3, that's 18. Let's go ahead and evaluate 3 squared and 2 to the third. So we have 9 x to the 16th times 8 x to the 18th. Now multiplying, 9 times 8 is 72, and for x to the 16th times x to the 18th, we add the exponents. 16 plus 18 is 34. We have 34 factors of x. So this simplifies to 72 x to the power of 34. Now we could have also expanded this and wrote out 2 factors of 3x to the 8th and 3 factors of 2x to the 6th, but this time I won't show that. Next we have 7b times 7b times 4b raised to the third. Looking inside the parentheses here, this is 4 to the first times b to the first. So we have powers raised to powers. So we have 7b times 7b times, this would be 4 to the power of 1 times 3, or 4 to the third, times b to the power of 1 times 3, or b to the third. 4 to the third is equal to 64, so we have 7b times 7b times 64 b to the third. Now from here, remember the exponents on the b's are 1, so now we can multiply. 7 times 7 times 64 is equal to 3,136, and then b times b times b to the third is equal to b to the fifth. 1 plus 1 plus 3 is 5. So we have 3,136b to the fifth. Of course, the other option here would have been to expand 4b to the third by writing out 3 factors of 4b. But as these problems get more and more involved, it'll be to our advantage to use the power to power property given here. I hope you found this helpful.